All right. Hi, guys. We're the AR Mural Group.
I'm Nima.
I'm Jovana.
I'm Nishi.
I'm Suhani.
I'm Sachin.
So, in the age of information, there are hundreds of digital applications out there. You guys may have used some of them: Procreate, Microsoft Whiteboard, and they're all great, but they have two big problems. First of all, they're not 3D. Second of all, we live in an era of teamwork, and teamwork is just not possible with these applications. As a result, we propose our solution, AR Mural. Now, some of you guys may be wondering what AR stands for. It stands for augmented reality, which is exactly what it sounds like, augmenting what already exists, adding things to it. Some of you guys may have played Pokemon Go, where you add Pokemon to your real world. That's exactly what it is. But here, it's for a collaborative art platform, which in real time allows you to collaborate with others.
So the technologies that we use for our projects, so we use Unity, which is a game development platform, which in combination with MRTK3, Mixed Reality Toolkit 3, in order to code and also to simulate and quickly test an AR environment. And then we also use Visual Studio as a middleman to build our project onto the HoloLens, a virtual reality headset used to actually use the project. And then we also, not last but not least, use MQTT, messaging, querying, telemetry, transport, which we use to build our server, which actually allowed for collaborative group work in real time. So our features, we have brushes, we have lines, we have shapes, we have text, we have deleting options. You can select your drawings, modify them, move them around, erase them, whatever you really want.
So the question is, now that with all the tools that we just talked about, how do we actually technically allow users to work with each other? So if one user draws something, how does the other user actually kind of see that show up on their screen as fast as possible in real time? And so kind of MQTT, we use MQTT on our own kind of Linux server. And the reason why we chose MQTT over other kind of communication protocols is because MQTT is really fast. Like it takes only a few milliseconds. And also it utilizes a subscriber publisher model. So if, like, it's kind of like a message board where you only get notified of things you're interested in. So kind of an example here is, there's 3 clients connected to our MQTT server, client A, B, and C. And pretty much if client A wants to draw something, it would send a request to the MQTT server. And the MQTT server would kind of review that metadata, make sure it's parsing correctly. And once it approves that data, it will kind of store the metadata with that drawing. So like the brush strokes, the color, the size in its own database. And then once it does that, it would propagate that metadata to all the other clients. So, and it would also send it back to the original requesting client as kind of an acknowledgement that, hey, like your request was approved. Now you can place it. And so that's why when you draw something in a few milliseconds, all of the clients would kind of have the data propagated and it would show up on everyone's screen. And kind of on the client side of things, we ran into a few optimization problems, which is if I were to draw something in WINLAB, someone in New York City would kind of have that command sent to their server or to their code base. But the issue was that it's so far away that you don't actually even see it, but you're still rendering it in Unity, which costs, like memory and it can add up. So we thought of our own kind of like chunk system, which we have, equally sized segments in the physical world. And the idea is that every client on their end would only render the drawings that they're near, like in the chunks that they're near to. So as we see on the left, there's a player in the purple and kind of the chunks that around them, it's the 3x3. And when the player from the left to the right moves up one chunk, it would kind of de-render all the chunks in red right here because now it's far away enough that it doesn't care. And then the chunks in green, and this is where the database for the server comes in. The client would kind of ask the server, hey, are there any drawings in these chunks in green that I can render now? And the client or the server would kind of review that, check its database, and return if there's anything.
So this is an example of this in action. So this is me recording in Unity. So I'm drawing some lines there. Nima's drawing those texts and Nishi is drawing those shapes. So some challenges that we ran into in this project. So the first one was a lack of MRTK3 documentation. So we had to spend copious amounts of time researching, using external sources in order to properly integrate the software into our project.
Another problem we had was integrating programs we would find on the internet with Unity because Unity runs in C# and most programs do not. So we had to find a way to blend all the programming languages together.
And kind of the third problem was localization. So kind of Unity and like, the physical world have different coordinate systems. So we had an issue where if I drew something like here physically, another kind of client on the HoloLens would see it somewhere different. So there's like a bit of offset. And we don't want that. We want users to kind of be able to point at the same things in the physical world and, like edit them, and it will kind of like be more immersive.
So this is our demo video that I recorded. So as you can see, there's a start menu that pops up when you deploy the HoloLens. And then I can draw a line. The default color is red. You can have the color palette, change colors, also our text tool. And as you can see, a keyboard pops up where you can type in words. There's also predictive text, so that can also streamline the text experience. You can change the color of the text, and you can pinch and drag to make it bigger, smaller. You can also have shapes. As you can see, I'm drawing a rectangular prism. You can also erase by pinching. And you may also move the menus around to your liking, pin them. And then I'm also going to use the select tool to select the rectangular prism, move it around, and then I will delete it. So this is a quick look around of things that were already drawn. So that's Aman, our friend. And as you can see, there's a variety of colors that we use. That's him like deleting some of the stuff. And there's some text that Nishi wrote. And I am walking around to the other side of the room to my drawings. And I use quite a variety of colors. I use like this sphere, the shape tools to make like the grapes. I drew a couple more things, but I mostly use like the actual drawing tool, variety of colors. And I also wrote my name there. So for the future, for this project that we want to do, and other groups are welcome to do this, we had undo and redo buttons that we used, but we didn't have time to fully implement those. We also had a shaped line tool option. So our drawing options, when you draw or use the line tool, they're just like a cylinder, but we had an idea to use like star shapes, square shapes, whatever. Didn't have enough time to implement those.
Something else we wanted to do was geotagging, which essentially means that every digital mural has a physical location. So you could have one mural on that side of WINLAB and one mural on that side of WINLAB, or on a larger scale, one in New York City and one in Tokyo. In addition, we want to configure our project to make it universal. Right now, it only deploys to the Microsoft HoloLens, but we want to make it so that this application is also usable for people who have the Oculus Quest, for example, so more people can use our application.
So the second part was the overlay, and essentially the goal of this is to overlay like a virtual skeleton or muscular system on top of patients in a future medical setting. So what is the overlay? Essentially, it takes camera input from whatever source that you choose, and it analyzes this feed to detect key landmarks of the body parts, and then it displays these landmarks back onto the feed and creates a virtual skeleton. So the features I implemented were the multi-pose versus single pose toggle. So you can choose whether it detects multiple people or just one. The video input option, so you can choose which camera source the feed is coming from. The confidence level slider, and essentially what this is, it's how confident the program is on where the body part is. So when you bring the confidence slider up, then you will see less body parts because the program is not that confident. And for the same reason, when you move it down, you'll see more body parts just because the program is not confident. And we also have the max poses slider, which is just how many poses that the program shows per frame. Here's a demo of it working on my friend. In the future, I want to integrate this onto the HoloLens. I tried to do it this time, but there were a lot of obstacles to overcome. So I hope to do this in the future. I also want to attach like a virtual skeleton onto the lines that I created, and just refining the system to make it faster is a future goal.
Beyond that, we just want to take a quick second to thank you, not only for Dr. Ivan Sesker and Jenny for all of their help and support throughout the summer, but also anyone who has helped us test our programs out, whether it's AR Mural or the Pose Estimator.
And yeah, before we wrap up, here we have a code that you can see, which takes you to a website where all the murals that we have created are on there, and information about us and about the project. And yeah, also you can come by our stand to see the HoloLens for yourself. And yeah, that's it. Any questions?